Hi everyone, and welcome to Geometry Lesson 5-6, which is inequalities in two triangles. So we're going to start off with the main theorems that we're using throughout this entire lesson. So let's see what they are. The hinge theorem is the theorem we're talking about in this lesson. And it says that if you know that there are two pairs of congruent sides in the triangles, and you know how the included angle, the angle that connects those two sides, compares to the included angle in the other triangle, you're allowed to compare the sides that are across from the angles. So if I know that angle A is bigger than angle D, then I can conclude that BC is bigger than EF. That's the hinge theorem. And the hinge theorem makes sense if you think about a door on its hinges. Like this is the doorway and here's the door. If the door is open just a little bit, there's not going to be much room for you to get through the doorway. But if the door is open a large way, so if it's a big angle there, then you're going to have a lot of space to get through the doorway. So the hinge theorem allows you to compare the sides. Now its converse allows you to compare the angles, the included angles. You still need to know that there are two pairs of congruent sides, and you need to know how BC compares to EF. And if BC is bigger, then the angle across from it is going to be bigger than the angle across from EF. Okay, so those are our two theorems, the hinge theorem and its converse. Now let's take a look at some examples. In example 1, they want us to compare the measure of angle PQS and the measure of angle RQS. So the first thing we need to do is make sure we have those pairs of congruent sides. So notice that PQ and QR are congruent because they have the same measurement. And then notice that QS is shared in both triangles. So I need to compare this angle to this angle. So see if you can make that comparison and decide if it's the hinge theorem or the converse. Okay, so this is bigger than this one. So this angle is going to be bigger than this one. So PQS is bigger. And I drew my arrow in the wrong direction. PQS is bigger. Okay, so I know that 5.3 is bigger. This one's bigger. And this is the hinge theorem's converse because I'm comparing the angles. When you compare the angles, it's the converse. Okay, so let's look at part B. They want us to compare KL to MN. Let's check that we have equal parts. I have ML is 6 and KN is 6, so those are congruent. And NL is in both triangles, so those are congruent. So I'm allowed to compare this angle to this angle, and then compare the sides. So try and do that, decide if it's the hinge theorem or its converse, and then press play to check your answer. Okay, so I know that 53 is smaller than 57. So MN is bigger than KL. So I can write this. KL is less than MN. Now notice in both of these examples, when I wrote my inequalities, I kept them in the same order that they were in the question. Okay, and that's going to just be more helpful because when they ask it to you and they show you an answer, they're just going to give you this symbol. So if you write them in the same order, that's good. Now I did forget to say that this is the hinge theorem, not the converse, because we know the angles and we're comparing the sides. It's the regular hinge theorem. Now we have one more example to do. Take a look at this one. In example 1C, they want you to find a range of values for x. So you need to solve to find out what x could be. Now it's not going to be a definite answer. We need a range of values. So let's first make sure we can use the hinge theorem or its converse. I know that UV is equal to VW because of these tick marks. And I see that my triangles share segment VT. Okay, so I have two congruent sides, and I know how the third pair of sides compares. So I am allowed to use the converse of the hinge theorem. So what you're going to do is you're going to write an inequality comparing these two angle measures. So pause the video, try and decide how they compare, and then press play to see if you're right. So I know that 24 is smaller than 25, so 6x minus 3 is smaller than 45. And I wrote 6x minus 3 is smaller than 45. Now you'll notice I did write two inequalities because they wanted a range of values. And I know that an angle measure has to be more than 0. So I wrote these two inequalities. Now, if you're really, really good with your algebra, you may recall that in Algebra 1 you learn about compound inequalities, two inequalities that have been stuck together. Because I know that this is the same expression, I can stick these two inequalities together like this. And I can solve it just like this. So I'll show you those steps. The first thing that I would need to do is add 3 in all the sides of my inequality. So 0 plus 3 is 3. This middle part plus 3 is just 6x. 45 plus 3 is 48. Then I'm going to divide by 6 in all these spots. 3 divided by 6 is 1/2. 6x divided by 6 is x. And 48 divided by 6 is 8. So this is my final answer. Now, if you had solved the inequalities separately, you would still get the same answer. You would just get that 1/2 is smaller than x, and x is smaller than 8. But you will still have the same answer. Now it's time for you to try it. So I have two questions here that you're going to try. Okay, so just put them in your notes and we will review the answers when you get back. In the first part, you need to compare the measure of angle EGH and the measure of angle EGF. Don't forget to show that you're allowed to use the hinge theorem or its converse. And then in part B, you need to compare segment BC and segment AB. And again, don't forget to show that you're allowed to use it and state which theorem you're actually using because I want you to practice that. So when you're done with that, press play for the last two examples of our lesson. In example 2, it says the angle of the swings in a circular swing ride change with the speed of the ride. The diagram shows the position of one swing at two different speeds. Which rider is further from the base of the swing tower? Explain. So first thing we're going to do is make sure we're allowed to use the hinge theorem. Notice here's the swing and it's attached to the top of the ride. And this chain that attaches the swing to the top of the ride can never change its length. So that distance is going to be the same in both pictures. And the height of the ride is also always going to be the same because the ride's not going to change how tall it is. So this part is going to be equal to this part. And as this ride speeds up, the rider is going to be pulled further and further out. So this angle here is going to increase as the ride speeds up. So in this one, this is a very small angle. And in this one, this is a bigger angle. So person B is going to be further from the base because of the hinge theorem. We know about the angles. We can see that this one is bigger than this one. So person B is going to be further from the base. Now we have one last example, and it's everybody's favorite type. It's a proof. Okay, so in example 3, they said given KL is congruent to NL, and they want you to prove that KM is greater than NM. So we're going to start the proof in the way that we always start a proof, by copying down the given statement. And then we're going to think about what's going on here. Okay, so I have my given statement copied down. Now I need to take another look at my picture and try and figure out which triangles they're using. What I've done is I've put some colors in the picture to help us out. Notice we know about KL, and we need to prove about KM. So KL is here, KM is there. So this blue triangle is going to be the triangle of interest in that one. Now we also know about NL and NM. So NL is here, NM is there, so I have this pink triangle. Now in order to use the hinge theorem, I need to show that two pairs of sides are congruent. And I notice that both of these triangles share side LM. So I'm going to use the reflexive property to say that LM is congruent to itself. Okay, so now I have two pairs of sides. Now I need to prove about the angles connecting those sides because I need to compare the other sides. So I need to prove about the angles across from them. Now, we don't really have a way to compare these. I do know that MLN plus this blue angle here, which is NLK, is going to equal MLK. So I can use my angle addition postulate, okay? But we don't really have a way to just compare these two angles outright. So I'm going to start with angle addition. So here's my equation from angle addition postulate. So I have this thing. Now there is a property of inequality that you don't know. And it's what we call the comparison property of inequality. And it says that if two angles add to a bigger angle, and neither of these angles is 0 degrees, then I know that MLN is going to be smaller than MLK. And I know that NLK is going to be smaller than MLK because they make it up. Because I know this one plus this one equals that one, and neither of them is 0. So these two individually will be smaller than the total angle. And that's the comparison property of inequality. So that's my next step. Now that I know how my angles compare, I can compare my sides. So the pink angle is smaller than the blue angle. So the pink side is smaller than the blue side. Now they wanted me to write it in this order, which is fine. I can write that the blue side is bigger than the pink side. So I'm just going to copy this down. And now I need to decide between the hinge theorem or its converse. Now notice, I know how the angles compare and I'm concluding about the sides. So that's the regular hinge theorem. So my final answer is going to be this because of the hinge theorem. And my proof is completed. So make sure you've taken good notes on this lesson. Bring in any questions you have when you come into class next time. And don't forget to have your notes done well. Okay, I'll see you soon.